In this video we're going to take a look at how to solve a system of two linear equations, meaning we have a y and we have an x in each equation. And we're going to solve it by looking at a picture. Basically, each one of these equations can be graphed as a line. All its solutions fall on a line. And if we can find where those two lines intersect, we can find a common solution, an x and a y that works in both the blue equation and the red one. So let's start by taking a look at a picture of this. We need to graph each one separately. So let's start with the blue one. Okay, that's already in slope-intercept form, so we're going to be able just to take a look at positive 2, that's our y-intercept, and our slope is negative 1/2. So I'm going to go down 1 over 2, down 1 over 2. And you can see the line looks kind of like that. Okay. Now, let's take a look at the red one before we compare them. And the way the red one looks, it doesn't look exactly like the blue one. We're going to need to divide by 2 in order to get this into something we can have like a usable format with, so that we can look at it easily and recognize some features. So this gives me y equals positive 2x minus 3. Remember, this is 2 over 1. So I've got to start at negative 3, and then I go up 2 over 1. Up 2 over 1. And I can see that this line's positive and it's going to intersect, and eventually we get an intersection point right here. Now let's take a look at where that location is. It looks like that location is at 1, 2 on the x-axis and 1 on the y, or at least that's what it looks like. Now what that means is an x value of 2 and a y value of 1 should solve both of these equations. So let's try it out and see. Let's take this equation right here. Let's put 1 in for y, because that's the point we think is a solution, equals 2 times x, and x in this case we think should be 2, minus 3. So if we calculate this, it looks like it's going to be 1 equals 4 minus 3. Is that a true statement? Yes, it works in that one. Now we have to check the other one too. We always have to check both. So if I plug in my values, I get 1 for y equals negative 1/2, and then 2 for x plus 2. And what this tells me is, if I multiply those right there, I got 1 equals negative 1 plus 2. Is that a true statement? Yes. So this is a solution to that system of equations.